Yes, I know. More equations, your favorite. So I do want to stress that don't be overwhelmed by these things. These are tools that you will learn how to use if you can do the guess method properly. So we have these three so far: average velocity, acceleration with time, and acceleration with displacement. Well, we have a fourth one that is basically our displacement formula. This is going to be one of our most common formulas whenever we do free fall, because luckily free fall has zero initial velocity most of the time, because most objects are just simply dropped for our purposes. So we can basically cross it out and just be left with this second half of the equation. It's really not that hard, it just looks a little scarier than it actually is. So let's actually practice with it. A van was dropped off of a highway. Assuming no air resistance, how high was the van if it took 0.89 seconds to reach the ground? So let's start off. When you see the word dropped, this is the important information you should get from that. Dropped, fell, other things like that tell us that our initial velocity is 0. The next thing you should get, our time is 0.89 seconds, and it is asking us how high it was. So that tells us we are looking for displacement, which you can write as the triangle D or simply as D. It's up to you. If the triangle, which is delta, is confusing you, ignore it. It's something that can be ignored and still give you pretty similar meanings. But if you understand it, it will help you in the long run. All right. And there's one other piece of information that, unless otherwise specified, will always be the case in our problems. Our acceleration is equal to negative 9.8 meters per second squared. We always use this because most of our problems take place on Earth. The ones that don't, we pretty much specify it. So this time we have this equation, or this, and this. Since we don't have a variable VF, we can't use the A is equal to VF minus VI over delta T. And we can't use our A is equal to VF squared minus VI squared over 2 delta D, because we don't have this right here. Since we don't have this, we can't use this entire formula, can't use this formula, and we have to use our new one, which is displacement is equal to VI times time plus 1/2 A times T squared. I'm just going to plug it in directly under here because it is a long formula and I ran out of room. You can do that as well when you're doing the other practice problems. So our displacement is our unknown, so I will leave it. Our VI is 0. Anything times 0 is 0, so we can just cross that out because it's equal to 0 plus 1/2 times 9.8. It's a negative 9.8, just as a heads up, times 0.89 squared. Now, if we plug this into our calculator, which I have my phone right here, so 1/2 times 9.8 times 0.89 squared should give you negative 3.88 meters. What that is telling us is we fell 3.88 meters. Okay?